All right, so this lesson is going to be about composition of functions. And really, we've done a lot of work with composition of functions. We're not going to do any operations today. We're going to focus on what it means to actually put one function inside of another. We're going to do that using a table, using a graph, and then I'm going to show you how to find the domain of a composition function, which can be pretty tricky. But again, as I've said in the past, what I like to do is after I do them without using a graph, I can then go to Desmos, graph my composition function, and just confirm that I have the correct domain. Okay, so in this first part, all right, function composition is only one way to combine existing functions, so composition. Now, before we did composition in Algebra 2, you would have done some work with some other functions like, other operations of functions like addition, subtraction, multiplication, and division. We're not going to do that today. And as I mentioned, right, when you see this symbol, right, kind of looks like a degree symbol. I've told students in the past to think of it as f of g of x. It doesn't actually stand for of. It's a symbol that means to compose. So when you see that symbol, that means you're going to be substituting one function in to another. So substituting one function into another. All right, so you guys spent many years before learning about composition about how to evaluate functions at usually like numbers. Sometimes it'd be variables or expressions, but usually it would be pretty simple. Like if the expression was a plus 2. All right, but most part you've been doing like f of 6, g of 4, h of negative 5, things like that. All we're going to do is take that, what you've learned, and kind of expand on it by, instead of using usually a number as the input, we're actually going to use an entire function. All right, so let's do a quick kind of review here about how to find f of g of x and g of f of x. So f of g of x looks like this. What you want to do is you want to take your outside function, which is letter f, and I write that function. But the way that I teach it is instead of writing 2x plus 1, I write 2 box plus 1. And inside that box, I'm going to put my inside function of g of x. So I put 3 minus x in parentheses. And yes, I'm going to do my simplifying of that. But let's just set up the other one first so you can see the difference. All right, so this is g of f of x. My outside function is the letter g. So I'm going to write 3 minus box. And in that box is where I'm going to put my inside function of f of x. So 2x plus 1. Okay, so from here, we're just going to simplify and multiply that 2 to get 6 minus 2x plus 1. And then on this side, we get 3 minus 2x minus 1, almost finished, negative 2x plus 7. And this becomes negative 2x plus 2. Now, again, that is just your basic review of how to do composition of functions. This question does say one more thing. It says to determine if the composition of this function is commutative. And that's a word that you probably learned for the first time in elementary school, talking about the commutative property, right? Multiplication is commutative. 4 times 3, 3 times 4 gives the same thing. So essentially, we're asking ourselves here, if I do f of g of x, or if I do g of f of x, do I get the same composite function? And when you look at that, you compare, this is f of g of x, this is g of f of x. Those are in fact not the same, very close, but they're not the same. So this composition is not commutative. All right, let's go to letter B. We want to interpret this composition C of S of 3. All right, so essentially what I'm doing is I want to think about taking my C function, which gives us the number of calories burned when you complete S number of sit-ups, and plug into that S of 3. All right, so S of 3 is going to give us the number of sit-ups a person can complete in 3 minutes. So C of S of 3 will give us the number of calories burned by a person who completes 3 minutes of sit-ups. All right, so the way you would do it is you would say, okay, go ahead, do your sit-ups. All right, for 3 minutes, you count them, then you take that number of sit-ups that they did, let's say, I don't know, 100, and you would take that 100 and put it into the C function, which would then give you the number of calories they burned completing those 100 sit-ups. All right, next page. We're going to do some work evaluating composite functions using a table, using a graph, and then getting into finding the domain of these composite functions. So when we compose a new function, we need to be able to evaluate it for any input in its domain. We will do this, all right, specifically by looking at tables, graphs, and formulas, as I said. In each case, we evaluate the inside or inner function using the starting input, and then using whatever we get for that inner function's output as the input for the outer function. All right, so when I went over this with students when I used to teach Algebra 2, I essentially told them that when you're doing this, it's almost like you're doing 2 for the price of 1. So essentially, you've got to do 2 evaluations to get your 1 answer. So for example, let's do f of g of 1. So when I do this, all I'm going to do first is focus on the inside function. All right, I know that's different than how we did the composition when they gave us the actual function. So there are many different strategies here depending on what you're given. So when I get a table, I just ignore the f. So I know you can't see me doing this, but I'm covering up the letter f with my finger. So g of 1 is all I care about, and g of 1 is going to be 3. Now, that's not my answer. That's just what g of 1 is. So what I want your brain to understand how to do is to do f of what g of 1 is equal to. All right, I'm not going to write g of 1 again because now I know that g of 1 is the same as 3. So I'm doing f of 3, and f of 3 is 3. So this whole process gave me f of g of 1 equals that last 3. All right, so that's how you do it. Let's try the next one. G of f of 4. So g of f of 4. Same idea. I'm only focused on the inside function, that f of 4. I'm essentially ignoring g right now. So I just want to do f of 4. And f of 4 is 1. That is not my answer, because now I need to do g of f of 4, and I know that f of 4 is now the same as 1. So g of 1, let me put it up here so the same function. G of 1 is going to be 3. So g of f of 4 gave me 3. All right, let's do the same idea, but this time with a graph. All right, we want to evaluate g of f of 2. So I'm going to just focus right now on evaluating the inside function, which is f of 2. All right, so I'm just going to focus on f of 2. So this is my f of x graph here. I'm going to x value of 2, and I get a y value of 5. All right, that's not my answer, because now I need to do g of whatever I just got. And my output for what I just got when I plugged in 2 to the f of x function is I got 5. So now I go to the g of x function, go to x is 5, and find the y value of 3. So g of f of 2 is equal to 3. The answer will not always be 3, just letting you know. That's just a coincidence that it keeps happening to be 3. All right, now let's do some composite functions algebraically when they give us the formulas. All right, so in this example, we want to do h of f of 2. All right, so I'm going to do h of f of 2. So again, I'm going to do the inside first. So I'm going to focus on f of 2. And then I'll plug whatever I get after I do that into my outside function, letter h. So f of 2, which is going to be 2 squared minus 2. So that's 4 minus 2, which is 2. Again, not my answer. But now I'm going to do h of whatever I just got, which is 2. So h of 2, which is 3 times 2 plus 2. So that's 6 plus 2, which is 8. So h of f of 2 is 8. Same thing for letter B. It's actually the same order. So I'm going to focus again on that f function, since that's my inside. And I'm going to do f of negative 2. So f of negative 2, which is negative 2 squared, minus a negative 2, so that's 4 plus 2, which is 6, and then evaluate the h function at my value of 6. So 3 times 6 plus 2, so that's 18 plus 2, which is 20. So h of f of negative 2 is 20. All right, now, in other classes, the teacher might show you how to actually find h of f of x first, right? You could take the time to find this value here, or h of f of t, I should say. But ultimately, whenever I'm given the two functions and asked to find an evaluation with an input of a number, I don't take the time to do that. The only time I do this is when they literally have an input here that's a variable. Then I will do that. But if it's a number, I'm not going to waste my time. I'm just going to plug in the inside, find that value, plug it into the outside. All right, so let's get to the domain of these composite functions. And there's some steps to follow, but I think I like to use a strategy that has worked for me in the past. So I'll show you my strategy that I think is the simplest way to do it. And that's to do the composition, and then from there, see what's going to give you any undefined or any issues like we've talked about in the past with domain, where you're looking at what makes the denominator become 0. That's an issue. Or if you have a square root symbol, what would make negative values happen underneath your square root symbol? So let's try this one. We want to find the domain of f of g of x. So I'm just going to do it up here. All right, so I'm going to do the f of x function 5 over box minus 1. And I'm going to put in my 4 over 3x minus 2 inside the box. So this is what I would say is a rational function, but you have a rational function inside that. So you've got, I know this is going to date me, but that movie Inception, where you've got dreams inside dreams inside dreams, you've got rational functions inside rational functions here. So maybe a spin-off in a math world. So what I do here is I first look at what's in the box. All right, another great quote from a very, very, very intense movie, Seven. What's in the box? So I'm going to look at 4 over 3x minus 2. And I'm worried about that because I have a denominator that has a variable. So I'm going to set 3x minus 2 equals 0 because I want to make sure that I find out what value would give me that. So I have 3x equals 2, so x equals 2/3. So essentially I'm saying don't use 2/3. You can use any number you want in that box, but don't use 2/3. Now, if you imagine, right, that box is going to give us some value when I plug in x, I need to be careful because then if I subtract 1, I could get 0. So now I'm going to set the box equal to 1, because if I find out the value for x that makes that true, that is another number that I need to be worried about or exclude from my domain. So I'm going to move that over to get 3x minus 2, then move the minus 2 over with addition to get that. So x equals 2. So essentially I'm saying here for the domain, you can use any number you want, so negative infinity all the way to infinity, but don't use 2/3, right? Because we said 2/3 would make our function in the box become undefined. And don't use 2, because 2 would make that greater composite function become undefined in the denominator. All right, so that is our, right here, this is our domain. Okay, let's try letter B. So same idea, I'm going to do f of g of x. So f of g of x, which is 1 over box minus 2. And inside the box, I'm putting the square root of x plus 4. So I have a rational function, and then I have a square root function inside of that. All right, so the first thing I want to do is think about what's going to make my box become or have an issue. So when I look at that, I have the square root of x plus 4 is in the box. I want to see what values, right, would make this become less than 0, right? Because again, when I'm looking at this, if I have values in for that x that make it a negative, I cannot take the square root of a negative number. So if I move that 4 over, I get values that are less than negative 4. So essentially what I'm saying is you can use negative 4, and you got to use something that's greater than that. So negative 3, negative 2, negative 1, all those numbers would also work. But anything to the left of negative 4 is a problem. Now, I need to also worry about that square root of x plus 4 becoming 2. Because if that becomes 2, then I have 2 minus 2 in the denominator, and that would be an undefined function. So I'm going to square both sides to get 4. Let me show you the work there. So square both sides. That square of a square root, those are inverse operations, so that's going to go away. Leave me x plus 4 equals 4, so x equals 0. So I'm essentially saying don't use 0. So I'm going to go with this idea that I'm going to use any value that's greater than negative 4, or it would also equal negative 4, that's fine, but I can't use 0. So the domain is going to be negative 4 to infinity, but because I can't use 0, I have to write negative 4 to 0, and then 0 to infinity. And all of those numbers would work. All right, let's talk about decomposition, and then we'll be finished. Decomposition. So in some cases, it is necessary to decompose, so kind of take apart a complicated function. In other words, we can write hold on one second. We can write it as a composition of 2 simpler functions. Where am I? Here I am. Found myself. Of 2 simpler functions. There may be more than one way to decompose a function. So the way that I decide to do A and B might be different than the way that you do it, okay? So when I look at letter A, it says to decompose this into 2 functions. So what I did was I wrote that the outside function, so I'm thinking the function where I write the box, is going to be the square root of 5 minus x. All right, because then if I wrote that as 5 minus box, I would need to plug into that box x squared. All right, so if I did f of g of x, it would become the square root of 5 minus x squared. Let's go to B. Same idea for B. All right, so my f of x is going to be the box, the one with the box, I should say. So 4 over, and I do 3 minus box. All right, so I'm writing 3 minus x. So then what do I need to put in that box? Where it says x, I need to put in the square root of 4 plus x squared. So as I said, there are definitely many ways to do this, but that's the way I decided to do those 2 in A and B. All right? Oops, sorry about that. So good luck on your practice, and let me know if you have any questions.